Hello there everyone, my name is Crazy Caleb, and today we're going to conclude the Vanilla Swirls 2 with Maze Code. So on this module, what you'll see here is a Morse code lookalike, but it's not the exact same, and it's a combination of Maze and Morse code. This is what we're going to be working with in this Vanilla Swirl today. So one of the big differences that you'll notice with Maze code, it visually looks a little bit different. You'll see what, like, you might, if you put them side by side, you might understand what exactly is different between them. There might be a little bit of a color difference, especially with the Morse light itself. It looks a little bit different, but the main difference is going to be with the message itself. The message itself is only going to be transmitting a signal from a flashing light as a series of cardinal directions that form a path. So what we're going to get is we're not going to get a Morse word whatsoever. We're actually going to get something that's is not going to make a lot of sense to whomever might be looking at it first, but it might make sense later on down the line. So let's wait for the sequence to end and let's get the sequence. So you'll see a brief pause, like on its own time. Now, so dot dot dash dot 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 dash dot 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 dash dot dash dash dot 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 dot, I believe, at the end there. I'd like to confirm that. Dash dot. Okay, so as you can see here, this is what we get, and as you can see in the manual as well, there's no Morse code like letter conversion that is going to give you. It simply says how to interpret, and a pattern of flashes and sort gaps represent a movement of one space in a cardinal direction. Different patterns represent different directions, and there's a long gap between directions, and there's a very long gap before the path repeats. So that's basically how to interpret it. And what we have here is we have the dot dots will be forming one group, effectively. So that'll be one direction. The dash dot will be another direction. The dash will be another direction, and we actually don't have all four directions. So the max that you can actually have up here is 4 different sequences of code that represent each different direction, effectively. So our goal here is we're going to find the only maze where the path can be traversed without passing through a wall or turning 180 degrees. Now, what the turning 180 degrees means effectively is if we were to go, for example, right, up, down, the next move we know for a fact cannot be up. The up would effectively force us to turn a 180 from the position we moved down from, so therefore that simply would not work. No spots, and just for the record, we will not be going over different spots. There will always be a unique path that will visit each spot exactly once. Very important to know that. So what we're going to want to do is we are going to want to look at these mazes here, and this is not a fun module. Let me just say this. I'm only going to do one example for this, and the submission for this is actually really simple, and I'll get into what we need to do later on with that. What our goal is now is we need to figure out where we are in the maze, and we need to figure out where we end in the maze, and which maze we're in, of course. So one of the nice things about what we have here is we have a lot of repeating characters. We have a dot dot, then a dash dot, then a dot dot, then a dash dot, then a dot dot, then a dash dot, then a dash. So what we have here is almost like a little mini staircase, if you think about it that way. What we want to look out for is stuff that's going to be alternating patterns, because what's going to happen here, we don't know which direction these things go to. This could be either one of these 4 directions. We don't know at this moment, but what we do know is that if we do either up or down here, we know the next one has to be left or right, or vice versa. If it was left and right here, we know that the next one has to be up or down. So it's a nice little way of thinking about it when you're looking at cases where you have a staircase, effectively. This is going to be nice because it helps you confirm what we're looking at here. So in this case, this might be like an up, left, up, left, up, left. Then it's going to go to some other direction, which we will not know at that current moment in time. So it's best that we just simply look for a staircase and we work with what we're given. And it's also nice to note that we ended with 2 of the same direction that we actually start with. So this is the part that we're going to have to do, and this is the part that sucks about the entire module, is just finding where it is. And we kind of just have to work with it. So just bear with me. This is going to be a bit of a slow tutorial. This is only going to be one example tutorial because it's really simple how to submit it. But finding this stuff is like finding a needle in a haystack. It's really not that fun to work with. So let's have a look. Let's see if we can find it, and let's see what we can work with. So our first goal is going to be looking for the staircases. We want to look for staircases that are 1, 2, 3, 4, 5, 6 spaces long. So we want to look for those. So we can maybe do this. So starting here, 1, 2, 3, 4, 5, 6, that could work. But if we look immediately afterwards, we need to have a different direction, which up would work. But then we need to have the exact same direction we had from beforehand, which was the second move, which if we want to go down and left, that would force us to go left. But in this case, from Quebec, we cannot go left, so therefore this staircase does not work. Now, if we were to try the other way, let's try this. Let's try it the opposite way. So from Whiskey, if we were to go right, up, right, up, right, up, then we, for example, have to go left, up. That would make sense. However, we cannot go that way because we start with a right. And we need 2 more rights after that, which in this case we end on the alpha. Right leads us into a wall. So unfortunately, as lucky as I thought I was going to be there, unfortunately we do not have that luxury today. So that's going to be ideally what we're going to be looking for here. It's very important to note that we're not going to be looking for any double patterns until the end. So you'll never see something like for example, starting from uniform. You'll never see this because we have to go up at least 2 spaces in order to get anywhere. Now, that could be an ending, but it doesn't make sense in this context. So let's find another zigzag. Let's see if we can work with it. Because that was a good starting point, but we obviously didn't get lucky at the end there. So maybe over at 1, we've got this here. So we got down, left, down, right, down. And it doesn't make sense that we can't go the other way. So, so in this case, we went 1, 2, 1, 2. Oh, we need to go back 1 more because that wasn't enough. So maybe let me try this. So 1, 2, 1, 2, 1, 2. Then bam, and then bam. But we can't go right. We can't go left either. Because if in this case, we would go left, down, then right down. Oops. Then right down. But we would then need to go left at this case, which we cannot do. So we're getting close to something. We're definitely on to something. And this one actually is a really nice example that we got. But as you can see, it is still very rough to work with. So maybe what we can do... and I was thinking about trying the other way around, but in this case, as you can see, it will not work. There's just not enough spaces to go 2 in a specific direction at the end. So I think that's going to be it for that maze. So let's go on to maze 2, see if we can find something else. From the 5, maybe 1, 2, 1, 2, 1, 2. So if we were to go in this case, down, left, down, left, down, left. That wouldn't work because we would have to go up effectively. Now maybe let's try 1 more space to being different. Or maybe, hold on, actually, it might be this way. Up, right, up, right, up, right, down, right. No, it doesn't work that way. Nope. Nope, not quite. So that's not that one. And that's all I can really see for zigzags here. Nothing else makes sense in the context that would be given, so let's move on to the next one. Could be something like this, maybe? So if we were to go right, down, right, down, right, down. Oh, it's so close. It's the fact that we can't get to the Zulu that wouldn't work. Up, left, up, left, up, left. We'd have to go down effectively, which would lead us to a dead end, unfortunately. So. I don't think it's 3. Let's move on to the next one. But yeah, these patterns are nice when you get them. Any other case kind of is really rough to work with. I don't even see anything in 4 that would make sense, that would work. 5 has something that would make sense, maybe. Let's see what we have here. So maybe we do a up, left, up, left, up, left, up. Left does not make sense here in this context. We cannot do that. Left up, left up, left up. Left does not make sense in this context. Maybe if we go the other way, perhaps it would make sense. So if we go, for example, down, right, down, right, down, right, up, then right, then down, down. Ooh, maybe we found it, I think, actually. Here we go. So in this case, from the 1, we would go down, then right, then down, then right, then down, then right. So 1, 2, 3, 4, 5, 6. Then we have to go up here because it's a different direction. Then we go right, which makes sense with the dot, with the dash dot. Then we go down, down, which is what we started with. We found our solution here. And as you can see, that took me 12 minutes. Thank God I found it when I did. So now we have our information. So now we know where we begin. We begin at the 1 and we end at the tango. So that's where we begin. So now how exactly do we submit this into the module? To set the frequency, we need to set the frequency such that it corresponds to the path, which includes the last 3 digits of the frequency. They must be the ID digit of the maze, the start of the path, and the end of the path. So that's what we need to do. And the ID digit of the maze has to be 5, and this is referring to the digits from left to right, by the way. So it needs to be 5, and then we start at 1, and then we end at tango. Start of the path, end of the path. And another thing to note is we need to now submit this. The frequency is going to be displaced in base 36, but it actually doesn't matter what you do with this, and there's actually a really simple way to avoid all of this sort of base conversion stuff. We don't need to actually worry about this. So to change the frequency, we're going to use the arrows, as you would suspect. Pressing an arrow will increase/decrease the current's frequency by its sensitivity, which is initially 1 Hertz. Pressing the TX button multiplies the current sensitivity by 6. It gets a little bit weird here. And pressing the TX a 5th time, it resets the sensitivity back to 1 and submits the current displayed frequency. So what we want to do here is and I'm just going to make this simple. This is a little cheat. We're going to want to set the first one, in this case the rightmost digit, to tango, as we've done here. Now what we want to do is we want to press TX twice, set it to 1, then press TX twice again. And as you can see now, effectively what it's doing is it's just allowing us to edit each digit, each position individually if we just press it twice. And also another important thing to note is the way that you can confirm that you've done it correctly is the start of the ID digit maze is only from the range of 0 through 9. It only allows us to go up to 9 in here as well. So that's how you can confirm that it is from left to right when it comes to 1, 2, and 3. So we're going to set it to 5, press TX a 5th time, and just like that is a solid module. The submission is a little bit, it makes it a little bit interesting at first, but it's really just set the first digit, TX twice, set the second digit, TX twice, set the third digit, submit. And just like that is a solved module. And that's all I have for you today. As you can see, that module can be a pain in the butt. It can get some really nasty sequences. In this case, that took me a little while even just to find that one, which is normally one of the easier cases to get. So, as always, thank you guys for watching. Remember to stay crazy, stay cool, and I'll see you guys in the next one. Bye-bye!